Hi everyone, I'm Siddhant and today I'll be explaining one of the most mind-bending problems of computer science, the halting problem. So this isn't just another theoretical problem, it shows the fundamental limitations of every single program that has ever been written, including the ones that you use in your daily life. So here I've made a simple web application which will aid in my explanation, and it has some visuals and examples which will help you grasp the concept better. So have you ever run a program and wondered that will this program ever stop or will it keep running indefinitely? This exactly is the halting problem. The halting problem asks that can we create a program which can look at any other program and its inputs and predict whether it will halt or will it go on indefinitely. Now, we'll see some examples to help you understand what we mean by halt and going on indefinitely. So let's take the first program. Here the condition is always going to be true, hence this program will be running indefinitely. So it will run in loop forever. Here it will print the statement and end the program, so it will halt. Here the value of the variable I increments in each iteration. So when it reaches 5, this condition becomes false and this program will halt. Similarly, here the value of variable n decreases in every iteration by 1. So after 10 iteration, when the value becomes 0, this particular condition will become false and hence the program will halt. So these were some simple examples that we are able to determine. But what about some of the more complex problems? Can we create some kind of halt checker which which can run on any given program and predict whether it will halt or whether it will go on forever? So this famous problem was proposed uh, by Alan Turing, and later he also proved that it is impossible to create such function or a program using a very beautiful uh, contradiction argument. So let's see about the proof ourselves. So the first step is to create an impossible magic function, the edge, which is the halt checker. Now, this function will correctly determine the halting behavior of any given program. As you can see here, given the program 1, it shows loop. For the program 2, it shows halt. For the test program 3, it shows halt. And the second step is the creation of a troublemaker program. So here I've shown an example of one such troublemaker program where it will do opposite of what Edge predicts. So if Edge predicts that the program will halt, it will go on to run forever. And if Edge predicts that it will go on to run forever, it will halt. Now this is the interesting part. What if we use the troublemaker on itself, right? So then if the program H says that the program troublemaker will halt, then the troublemaker will loop forever. And if H says that the troublemaker will loop forever, then the troublemaker will halt immediately. So in both the cases, H is wrong. So our original assumption of H being able to predict correctly in every scenario has now been contradicted, and hence we conclude that such a function H cannot exist. Now, this is not just some theoretical problem, it has some real world implications in computer science. For example, your code ID can't always uh, warn you about the infinite loops before running the code. Or take the example of antivirus software. Some malwares could theoretically hide by making detection equivalent to solving the halting problem. And thus, creating a perfect malware detection system is impossible due to this halting problem. And there are many such paradigms or examples that can be shown in computer science, which in the end point to the halting problem. So the key takeaway is that the halting problem shows us that there cannot exist any function which can correctly predict if any other program or function halts or goes on forever. And it's a beautiful example of how self-reference can sometimes creates impossible event. And it goes on to show that there are some problems that are fundamentally unanswerable through computation. So I hope that you have understood uh, this interesting halting problem, and thank you.